Hi there, and welcome to part 6 of my SDA demo using Zero Touch. My name is Roddy Hassan. I'm a technical solutions architect at Cisco Systems. Let's get started. So one of the things we forgot to do, or I forgot to do, in the last video was actually add the WLC to the fabric. So that's important, obviously, if you're going to want fabric-enabled wireless. So again, it's very similar to how we added the edge, the control plane, the border. We just click on the WLC over here in the topology view and click wireless, click add. There's a lot of other information you can look at when you're in those screens. I don't know if you saw the options, but there's a lot that you can look at. We're just going to click deploy and apply. You can see a little W there, a little W icon as it was outlined in blue. It's going to go ahead and update the WLC. It's going to push the virtual networks to the WLC as well as the pools, and it should come up in a solid blue once that's done. It only takes a second. Another thing I do want to show you, if we can get into it. So remember, my Fusion router is pre-configured, so I already had the SVIs created and the BGP peers created. I already knew what IP addresses to expect. But if you're doing this from scratch and you selected all of your VNs for border automation, and then you wanted to go ahead and configure your Fusion router for the other side, it's very simple to go in and just click on the border here and look and see what is actually on the device, right? So we can actually look at the configuration. We can actually see, if we go into details, we should be able to actually see what the border addresses are. I'm going to fabric, details, and you can see here gig 102 was the interface that we selected for our border automation, and we can see here for each virtual network what the VLAN ID is, right? So you can create your SVI on the other side, or your match your .1Q VLAN tag. And we can see what the local IP is. So this is for CP border 1 for InfraVN, and this would be the address you would use on the Fusion router for InfraVN. And same with campus. This is for campus, this is for guest, and this is for campus. This is .9. The other side would be .10, etc. So even if you don't do it one at a time the way I did, if you wanted to go ahead and do everything at the same time and then build your configurations after the fact, you can just pull up this screen here and you'll see what the remote IP should be. So let's close that out. We can see here our WLC now should be highlighted in blue, and it is now part of the fabric, and we got a little W there as a WLC. So the last step, last couple steps here before we can actually bring in our clients is to go to host onboarding. And again, this is a workflow type of system, right? It's made to go screen to screen to screen as you progress to build your fabric. So the very first thing you need to do is select an authentication template, or a default authentication template. And if you're familiar with .1x or host authentication in general, these terms should be pretty familiar to you. However, you can highlight over the tooltip here and it'll tell you what they mean. So in this case, we are going to use .1x. You can edit it if you wanted to change some of your .1x parameters, your authentication order, your failback timers, wake on LAN, etc. But in this case, I just want the defaults. I'm going to go with closed authentication, which means it's going to configure the fabric edge switch. It's going to configure all host ports as .1x. So again, if you're familiar with host-based authentication, you know what that means, you know what the ramifications are, but essentially it's going to push every port to .1x authentication, which means every host has to authenticate somehow, whether it's a username and password, or MAB, or guest, or whatever kind of authentication ICE supports. We can cover it here. So we're just going to go ahead and deploy that. Now again, this is just the default authentication template that will be applied to all ports on the fabric edge switch. If you wanted to override some ports, if you had a couple of ports that you knew were going to connect to an AP, or you knew you only wanted one kind of endpoint on them, you could go into port assignment here and scroll down to your edge switch and select a port and override the authentication template or the VLAN setting or any parameter that you want to override. But by default, we're going to go with closed authentication on all ports. Next step is to actually assign our IP pools to our virtual networks. So we already built the IP pools earlier before I started the demo. So we're going to go into campus here. We're going to add an IP pool. We've got one for San Jose called San Jose Campus Pool. Go ahead and select that. This VLAN name is literally the VLAN name on the switch, but it's also used by ICE to assign a host to the VLAN. So I'm going to shorten it to campus because the way I built my authentication policy, my authorization policies in ICE, ICE will actually push the VLAN name campus to the edge switch, which will put the host into that VLAN. Scalable group, you don't have to select one here. This is the default VLAN to scalable group or VLAN to SGT mapping. It is only used when you don't assign an SGT. Or it's also used with extended nodes, which again is out of scope for this demo. Type of traffic, in general, you're going to want data. If you pick voice, we'll actually push voice macros down so that you can have voice and data on the same switch port. Again, out of scope, a little bit more advanced. There are some other settings here I'm not going to cover. Wireless pool, I do want to enable because I am going to use this pool for both wired and wireless hosts. And selecting this box will actually push the pool to the WLC as well as the fabric edge switch. So we're going to go ahead and click add and deploy, and we're going to do that now. And then we're going to do the same for the other two VNs, right? So guest VN is going to follow the similar flow. We're going to click guest once this stops running here. It does take a second, so I will stop moving my mouse cursor around since I know that's distracting. So we're going to click guest. We're going to click add again. We're going to pull down. We're going to find our guest pool, which we'd already created. I'm going to shorten the VLAN name to guest. Again, it just matches my authorization policies. You can really use whatever you want as long as you match them in ICE. It's data, and we are going to enable this for wireless. We're going to click add, deploy, and apply. And then the last one is going to be for InfraVN. So remember I mentioned InfraVN is special. InfraVN is for infrastructure type of devices like access points and extended nodes. So in this case, we are using them for access points, so we do want to assign a pool to them. We're going to go click add. You can see that this dialog box is different because InfraVN is special. We're going to pick our AP pool. If we had extended nodes, we could pick our extended pool. What type of pool is it? This is for APs because that's what we're doing. My VLAN name or my authorization policy is AP VLAN, so I'm going to change the name here to match that policy. Again, you can use whatever name you want as long as it matches what your ICE authorization policies are set to. And go ahead and click deploy and apply. So that's actually it for wired. So from a wired perspective, I could right now, and I can do this, I'll do this in the next video, I could bring up a wired client, authenticate to the network using some authentication parameters that I've already set up in ICE, and I will be put into one of these virtual networks, either campus or guest. So I'm going to go ahead and do that in a minute, but the last thing I'm going to do is on top of assigning pools to your virtual networks, you also have to assign them to each individual SSID, since SSIDs can have more than one pool. So you actually want to have to assign a default pool to your SSID. So in this case, for our campus SSID, we want to select the campus pool, that's the VLAN name that I changed earlier in the flow. And for our guest SSID, we want to select the guest pool and deploy. So again, this is going to go ahead and it's going to push these changes to the WLC. Now everything should be able to work from a client perspective. There is going to be one more step to get wireless working, and which is we need to actually provision the access point once the access point gets discovered by DNA Center, and we'll cover that next. So by now our access point is hopefully in our inventory, in our device inventory, and I'll kind of try to explain how that happens. So if you remember, we assigned an IP pool to the InfraVN VN, and I put VN in air quotes, but that pool was for access points. If you remember, it was called San Jose AP pool. And so what happens is Cisco DNA Center will go ahead and configure that pool on the Fabric Edge node. It'll create an SVI for it. I have ICE profiling the access point using MAB and then discovering that it's a Cisco access point and then putting it into that pool. The AP will get an IP address from DHCP, and then using the traditional way that access points can discover WLCs, in my case I'm using a DHCP option, the access point will reach out, create a CapLap tunnel to the WLC, and then DNA Center will actually discover the access point via the WLC. So that happens. It takes a few minutes for the AP to boot up and get profiled, change VLANs, and then get the connection up. So we can see here now we've got our access point. It's got an IP address and it's in our inventory. And we didn't discover the AP directly with DNA Center. Again, we discovered it through the WLC, and that's all automatic. The Cisco DNA Center will synchronize with all devices every few minutes, and we'll take an inventory, and it sees that there's now an access point associated with the WLC. So that's done. The access point is here. And the last step to enable Fabric to turn on Fabric-enabled wireless is that we actually have to provision the access point. And the main reason for that is we have to assign it to a site. So we just check the box beside it, hit provision, go over here to provision device. Our first option is to choose a floor. So our clients are sitting in San Jose Building 13, Floor 1, so we're going to put that access point there. And again, this is how Cisco DNA Center will tie access points to SSIDs, to WLCs, etc. This is kind of where everything kind of comes together. So we just go ahead and click Save, click Next. We pick an RF profile. I'm just going to use typical here. Again, this is more wireless stuff versus SDA specific, so I won't cover it. We see here just our typical settings, what's going to be pushed to the WLC or to the AP. And we click Deploy and Apply. So part of this is that it will apply these settings to the AP, and some of the settings will require the AP to reboot. So that only takes a couple minutes. And then once that happens and once the AP comes up, it'll actually start broadcasting the SSIDs we created earlier. So while we wait for that to happen, because that'll take a couple minutes, we can actually test our wired fabric. We did host onboarding earlier. We signed a pool to our VN. And we've got a client here, and I'm just going to enable the NIC. It's going to ask me to authenticate. So I've got, remember, we talked about our HR and our accounting users. So for this one, I'm going to log in as an HR user, give it a password, and I'm going to show you in a minute what happens here. But go ahead and click OK. We'll see here that the NIC is identifying, and hopefully it comes up with a network. Boom. It's on the network now. We're on the Fabric. This is a Fabric-enabled client using wired networking. If we go here to our command prompt, we can type ipconfig. We can see that we get an IP address in our pool with a default gateway. And I can go ahead and ping the default gateway, and it's reachable, right? So we're on the Fabric. We've actually completed our SDA Fabric, and we've completed a client test, and we're able to actually ping across the Fabric. If I were to open Google Chrome, I should be able to browse to the internet. So if we just go to good site, let's go to Amazon. I can never pick random sites. You can see here that it loads up, and we're connected. So that's it. Our wired connection is done. Our SDA client is connected. And by now, the access point should have rebooted. So now let's go over to our wireless client here. And if we go down here and look at our wireless networks, we should hopefully see our two SSIDs that we created. So we've got a campus SSID and a guest SSID. So let's just open guest so I can show you the portal, the guest portal that we created during the guest workflow. So I go ahead and just connect to it. And by default, most operating systems and devices will actually try to reach a website when you connect to Wi-Fi. In this case, MS Edge or Microsoft Edge tried. We're getting a certificate error because we don't have any production certificates on our ICE server, but I can go to the website, and this is the hotspot that we created earlier during the flow. And go ahead and click accept, and we should be onboarded and go through the guest flow that I showed you in ICE earlier, and we should actually be on the internet or be able to hit the internet. So again, our guest wireless is now working. We saw the hotspot. We saw that I had to go and click OK in the portal. If I go to a website here, just go to dallasstars.com for lack of a better site, and the site will load up, and I'm on the guest network. So the very last thing we want to do is now connect to our campus wireless network. So again, we pull down or open up our wireless settings here. We can see the two SSIDs. We're going to now pick our dev campus SSID that we created. Go ahead and click OK. So again, we're asked to authenticate because we did enable this for .1x. In this case, I'm going to use an accounting user. So accounting2, give it a password, and connect. And see what happens here. So we should hopefully connect. There we go. We're connected, secured. I'll go back to our web browser here and pick a different site, tesla.com. We should see it load up, and we're on our SDA Fabric again as a user, right? So if I look at, if I open a command prompt and type ipconfig, we should see an IP address again from that campus pool. So we do 100, 100, 0, 24. If we go back to our client one, we got 100, 100, 0, 21. So we're actually on the same subnet with both a wired and a wireless client. And we should have connectivity. If I ping over to 100.100.0.21, I should see connectivity. I can ping between my clients. One is wired, one is wireless. Keep that in mind. So one of the big differences here with SDA is that wireless clients are treated like wired clients, and everything is locally switched on the fabric edge. I can ping between them. And the next thing we're going to do is go ahead and create a policy to actually block those pings so that you can see policy in action. So before I actually demonstrate the policy, let me take you into ICE real quick to give you a little bit of an idea of how the authentication and authorization mechanism works. Again, this is probably, it's a topic all by itself, and some of this stuff is, or most of this stuff isn't actually specific to Cisco Software-Defined Access. A lot of it is just your standard .1x network authentication, network authorization stuff, but we'll show you. So I guess the first thing we'll go in order here. If we go over to policy elements, when a user logs in to your fabric, they're going to type a user. If you're using .1x, they're going to type a username and password. There are other ways to authenticate. You can use certificates, you can use MAB, you can use a variety of different ways. Basically, anything that ICE will support will work with Cisco Software-Defined Access. But in our case, we're just using .1x, 802.1x with usernames and passwords. Once and I'll show you the actual policy set in a second, but once the user is authenticated, ICE will push one of these results. So in our case, we're going to look at the campus user wireless result just to give you an idea of what happens. So we're actually pushing a couple of different things. So for wireless, you have to use a different attribute for now. Let me show you wired. It's a little bit clearer on what happens here. So if we go back to authorization profiles and we look at our campus user for wired, we come down here, this is the result. So once this is after the user is authenticated, which I'll show you in the policy set, what does ICE do? So ICE will actually do two things. It will push a VLAN name to the switch. So it's telling the switch, okay, I've authenticated this user, put him in this VLAN. And in this case, the VLAN name is campus. And if you remember when we actually set up our pool to VN mapping, we changed the name of the authorization profile. That's for this purpose. And this if we were to look at the fabric edge switch and do a show VLAN, we would see this VLAN name campus, which is our 100.100.0/24 subnet. So it pushes the VLAN name, which puts the client into that VLAN, and everything will just kind of work from there. The other thing that ICE will do, just scroll down here a little bit and try to find it. Oh, it's actually in the policy set. So let's jump over to the policy set. Go in here, and you can probably tell that I'm not a very experienced ICE person. I can get it working for SDA, but not much else. So scroll down here for our policy sets, and we've got a bunch of them. We're not using most of them for this demo, but if we get on here and we find our HR user, so we can see once if the user logs in with an HR user, we've got a user database in the back end here. If he's part of the identity group HR, call that results profile, which is the profile I just showed you that pushes the user into the campus VLAN, so campus user wired. And then the other thing that ICE will do is it'll push the security group. So in this case, it's HR. So a security group is a scalable group tag, an SGT, whatever you want to call it. So now all traffic that comes in from that device or from that user will be tagged with the HR SGT. And that's really important when it comes to policy. So now let's just go into policy. So we'll go back to the client and we'll actually start a ping again to our wired client. So if you remember, it was 100.100.0.21. And I'm just going to set a ping to go for infinity until I stop it. So you can see here the pings are successful. I'm going to quickly go back into DNA Center, go into the hamburger menu, go to policy and group-based access control. And we're going to see our policy matrix here. If you're familiar with ICE, ICE has a similar policy matrix. This is the same matrix. It's just DNA Center's view of it. And we click the intersection here on the matrix between HR and accounting. So we've got HR across the top, accounting on the left. We just click that intersection. We can change our contract. So contracts can be very basic, deny, permit IP, or they can be more granular with TCP, UDP, ICMP types and port numbers. So in this case, again, very simple. We're just going to pick a deny IP contract. We're going to change it. So basically, we're going to create a deny IP secure group ACL, and we're going to apply it to HR or accounting to HR traffic and deny it. As soon as we click save, it'll add the policy. It's actually going to push this policy to ICE. ICE will then in turn push the policy down to the Fabric edge nodes. Any edge node that has an HR user will get this policy that says deny accounting to HR. Click deploy. That actually is the final step to push it to ICE. And if we look back at our client, we should see that our pings have stopped and they're starting to time out now. Very simple policy. Again, I'm just doing it just for the purposes of demo, but that's it. That's how it works. And if we go back to DNA Center, click that intersection again, we're going to set our policy back to the default, which our default in this matrix is permit IP. But again, your defaults could be deny IP. So you could by default deny all traffic and then explicitly allow traffic via policy. It's gone ahead. It's set it to default. We can see here there's no red block here. We hit deploy. If we go back to our client, our pings have started working again. So that's, again, very, very basic demo of policy. I didn't want to get too involved in it, but I also showed you a little bit about how ICE handles its authentication and authorization. And just remember, ICE will push the VLAN name and the SGT to the Fabric edge node so that all traffic from these clients will be marked with the appropriate SGT. Thanks for watching this video. In our next video, we're going to get into some multi-site and maybe a little bit more policy and wireless and Fabric in a box, and then hopefully wrap it all up.